Okay. Right, so we're going to look at solving the first problem in the week 9 challenge, which is to look at Exfiltrator and complete the new version, which really means completing a single class so that objects made from it do what they're supposed to do. So fire up an editor first. And I will also, before I forget, do the screen key thing. So screen key. That works. Make the screen better.
You're not sharing your screen either, James. Don't forget.
Okay, right. Sorry, I'm just doing bits of setup. There we go.
Okay.
Ready. All done. Let me share screen. Yeah, sorry, I'm talking through it like you can see, aren't I? Sorry.
Yeah. That's the only reason why I brought it up is because you were talking through it like we could see.
So just move that up a little bit more. There we go. So just getting myself set up. So I've got an editor open. I've got the screen key thing going. I'm going to just chuck that over onto desktop 4 out of the way because I don't need it to be near where we're working. Get my big chunky terminal for videos on. I think I mentioned before, but the only reason I changed to this one is because I can. It's a quite a nice terminal anyway. Your XVT is actually quite a nice terminal emulator, but it lets me can put borders and stuff on. So I know I've got like a safe space. Like it's not everything's going to get tidied up, and it's easier to see. I think when you have like this dark background and borders and stuff. So that's why there's nothing special about it other than that. And we're going to, in fact, what I'm going to do is I'm going to make a branch to do this development in, because we've been talking about branches now. So I'm going to do that. So I store my stuff in checkouts and Exfiltrator. So the first thing I'm going to do is a pull, just to make sure we've got the latest version. I'll do it in the prompt. If I start talking about Git and then it looks like I'm not using Git, by all means shout. It's because in my normal daily life, I don't tend to use Git from the command line, but do it from inside Emacs. And so I say, let's do this, let's do that. And then all of a sudden stuff happens. I'm actually doing those things. I'm just not doing them by typing the commands in. So just bear with me and feel free to pull me up on it if I forget. So check out. I'm going to do git pull and no tracking information. Oh, because I'm already in this branch, aren't I? So I thought I'd already done this, but then again,
created it and not pushed it yet, mate.
No, this is the pushed one. This is the pushed one. But I think this was the original one.
Bet you didn't track it.
I think that was it. So origin. Okay, so now all I've done is I've attached, if you like, this local branch to the remote one. So if you follow the way I showed you to do it, this isn't a problem. The reason it's like this is because of the way I did it. Okay, so this was actually the original, and for some reason doesn't track on the initial push, which is interesting, and I'll look into that later. But still, so git status. We're up to date with that. So git pull won't really do anything, but we can just use it to test that fixed. So you can see all I did was set up stream 2. It's fairly self-explanatory, and it actually tells you what to do in many cases. Git, I think, is about as user-friendly as it can be for a command line program that does something really complicated. But what I'm going to do is I'm going to do git checkout. I'm going to make a new branch, which is going to be week 9 answer. Okay, and then what I can do is I can push this up to the repository later, so you'll not just have the video, you'll also have a branch with the answer in it, so you can start comparing across. So we can do stuff like that now. We've covered that topic. Okay, so there we go. We've switched to a new branch. we're now in week 9 answer, and because I started the branch from objectified, that means that it's related to that in the sense that it starts from that point. If we, in fact, we could probably just it's a little bit of an aside to this, but if I just sort of touch one of the things, you know, I actually need to edit it down to type for this to work. So I just put a little change in there. Okay, you can see this is why we had that problem before, because it doesn't have the upstream. So all I'm going to do now is tell it that that's what I want it to be. Okay. There we go. And hopefully, if I fire up Firefox, we'll be able to go and see that that branch is now up and visible. So as I'm doing this, I will try to push, you know, as we go along and we get to certain points, so you can pull even before the end of the session. There we go. So you can see that we have these branches. We can see here's the thing, and the web interface even allows you to do like sort of pull requests out to join things and merge them, which again we're not really going to get into. We're just doing the basics for this module, but next year in the programming we'll use more of these features as we do larger scale work. But you can see this was the edit. There it is. It's all online. I don't know whether maybe in Insights. So GitLab has a really nice view of this. So this is a bit different, but it kind of shows you visually where the things are, so you can kind of see where other people have forked stuff. That's quite fun. So I can see other people working on things. So you can see mine there, and you can see where people took their forks from and where the things are. So I suppose probably what I need to do is. No, I don't think it does show. That's a shame. Maybe commits. No. Okay. In other Git repository software, you actually get to see branches visually, like we saw in the simulation software. I'm just going to try one thing just to see if it's because I'm already looking at master anyway. Okay, so we can't visualize it in quite the way we would with GitLab, but you can kind of still see, you know, we have these multiple branches. Okay, so I'm going to work in here, and I'm going to go into the source. Remember that the thing that we need to complete is this catcher, and so far it's just got a lot of comments in. Okay, and hopefully the comments will mean that we can solve this fairly easily. So firstly, just to remind everyone what it is that the catcher is supposed to do. The catcher is an object that is supposed to be passed into some other bits of code, so that we can say, right, this catcher will catch data that's meant for this particular file name, and it will use a particular decoder to decode what comes in, because we know it's going to be encoded somehow. And there'll be an output directory where we will dump the stuff when we're asked to save it. Okay, that's it. So it actually tells us in here some of the things that we need to create. So we'll put those in now. We need self.filename, and that's actually just equal to the file name that we're given. So if we're told this one is for collecting up the password file, then this will probably just contain password, PASSWD. Then it says collector, and this is a collector object. Well, let's just have a quick look at the collector object, because we remind ourselves, what does the collector do? Here's the start of the class, and it says it collects up chunks of encoded data into a single blob. Blob is a technical term, believe it or not, for chunks of like, binary data, things that you don't care about the structure of. So just it's a blob of data as far as we're concerned. And this has a decoder and it stores all of its stuff. It doesn't really know about file names, as in, you know, where they're coming from over the network. It's completely generic. Okay, whereas catcher is going to use a collector object, but essentially it becomes like an adapter to make it into a useful object for this particular project. The collector object might be useful in other places as well, but if we started to use all of this terminology from catcher in here, we would over specialize and we'd never be able to really reuse collector apart from in much more similar situations to we currently are. So by separating the two things out, we can actually make use of this in here to you know, leverage this functionality, if you like, without having to over specialize the original. And we do it here. Now we could use inheritance, but like I said before, in Python, it's actually usually preferable to use composition instead of inheritance, because we don't have the same requirements for these really pure namespaces and hierarchies of things. Duck typing and things like that mean that, you know, as long as it does what it's supposed to do, as long as it does what the rest of the code needs it to do, it doesn't really matter what type it is. Okay, so we make classes in Python because they simplify our design, not because we need to have this for any kind of security purpose or for type checking purposes, right? Okay. So a collector then is going to be equal to a new collector object, and we've already imported collector over here, so we've actually got this in our namespace. So collector is the module. Okay, been trying to help me. So that's the module, and inside that is the collector class, and that will then call the constructor to create a new object. Well, let's go and have another look at what the constructor looks like. So self, well, that's implicit. Okay, that's always there on these things. We don't need to type it in. It's just automatically there. Sorry, we don't have to type it in here, is what I'm saying. Obviously, I typed it over on this side. Then it has a decoder and some starting data. Both of these have some defaults. Defaulting to an empty data byte string, that's fine. But defaulting to the default decoder, which is essentially does nothing, isn't fine. So let's fix that problem. So we need to give it a decoder. So decoder equals base64 dot base64. I just invented a new encoding mechanism called base65. Base64 dot b16 decode, right? So I'm passing in a reference to that function. Now I am going to have to import that. So base64 to get access to it. All right, there we go. So we're going to put those things in. Now I've just imported a new thing and I've told it we're going to be this. And do you know what I've done? I've actually made this over specialized. So what I really want to do is to have it passed in as a parameter. Aha, here we go. Decoder being passed in as a parameter means I actually can just say whatever I was told the decoder is, let's just pass that along. And now I can also not bother with that import. Okay, so this is, again, part of the generalization. The things that are specific about our current problem don't necessarily need to be encoded into this. They can just be part of the data, part of the attributes that go with it, or part of the way it starts up. Okay. Self.dirty. So this is the flag, and again, this is a commonly used term to mean whether something has been changed or not. And so let's say you've got, so you open up an image in Photoshop or Paint or GIMP or something like that. You've got that. So has this been saved or not? You make some changes. That's considered now dirty in the sense that it hasn't been saved, and therefore it needs to be saved. Otherwise, you will lose that data. Same in Words and other things. So it's quite a common thing. You also get it in a technical sense in things like drawing on screen. You'll quite often mark areas of the screen to be dirty in the sense that they need to be the buffer needs to be flipped to display them. So you can selectively redisplay parts of a screen. So it's a fairly common term, but it just means has something changed or not. And I think we should start these as false because to begin with, they won't have any data. There's nothing to save. Therefore, all of the data that needs saving is saved, which I know is a slight flip in terms of logic, but actually does make sense in terms of propositional logic and that kind of stuff, or set theory. So we'll stick with that. And self.path is going to be equal to the place that this will actually be saved to. And if you look, it says the directory and file name in which to write this. So it's output directory plus file name. And for me, this is where I would use a path object. Okay, so you don't have to, but I'm going to import pathlib, and I will say this is going to be to pathlib.path, and we'll start with the current output dir, and then we'll add on to the end of that the current file name. Okay. So all we're doing is that bit of setup. We're just constructing the object and storing the data that needs to be there. So that's usually the case with the constructor, that you've got a lot of things to store. You maybe have to set up some internal variables with bits and bobs, but in this case, nothing really complicated. And now we have three things to do. Well, append should append the given data to the collector object. Okay, so we're going to get some data. It will be encoded. We need to get it to the collector object and have it appended to what the collector object can do. Well, the collector object will deal with all of the decoding and stuff, so we don't need to worry about that. What have we got? Oh, look, we've got an append. Okay? So actually, all we need to do is do self.collector.append data. Now, the difference between the catcher and the collector is the catcher is aware of file names, and that this is going to be written to disk and whether something's been saved or not. So what we're also going to do is we're going to say self.dirty equals true. So if someone's added data, and it hasn't been saved yet, and it certainly hasn't at the point that this append function will be called, it means that we have some data in memory that's not on the disk. And so we'd say, right, this is dirty. This is useful if you extend in the code later. You might go, all right, you want me to quit? Let me just make sure that anything that hasn't been saved is saved. Okay, and you don't go and write what's potentially thousands of open files if there's been no changes. You would look through and only do it to the ones that have been classed as dirty. Okay. How do we write it to the disk? I tell you what, let's come back to that one because this one's super easy. So let's just do this one first. What is the length of the catcher object? Well, length in this sense surely means the length of the data that we're working with, which means we actually want the length of the collector object because that does this stuff already. Okay, so you can see we have this stuff set up, and because of that, we can just do length self.collector. Okay, so that's that done. Right, now saving to the disk. Well, this is not really that complicated, but it's just the more complicated one of these things. And one of the things you can do is you could look at how we did this previously, right? You can actually go and just look up the code for this. So what I'm going to do in here is I'm going to say with self.path, is it open? Or no, it's open self.path, sorry. See, still not used to some of the Python 3 things. And we need to give it a mode. So I previously was using append. I'm not going to use append anymore because as far as this object is concerned, it's always just going to write to a fresh file. It is actually a problem for the wider application, whether it loads from that first and then writes or whatever. So for now, we are just going to write. So W for write and B because we're writing stuff that we don't know about. So we're going to say it's binary, which means whatever data we've got, we'll write. If it includes carriage returns and stuff, they go in as they are. They won't get changed because we're on a particular operating system. I think I've got the syntax right for that one, but we'll know when we try it. And so we want to write this to the disk. So we say f.write self.collector.data. That's it. That's done. And what do we need to do with dirty? I can't see the chat, so if you're answering in chat, Adam, can you pass on? But as a question, what is the correct state for the dirty flag now?
We've got set to false.
Yep. Because at this point, we've written to the disk, and we can say we're no longer unclean in the sense that we haven't saved it. Okay, and that's it. That's all the stuff that we need. The task does require you to also write in, doc strings. It requires you to write the tests for it. We're not going to go through those things. We've gone through them a few times with other things, so hopefully people don't need me to go over that again. If we do at some point, let me know. We can always do that maybe as a topic for Monday or even next Friday, and do a little video on the testing and documentation. But I think we've kind of laboured that point a few times already, so I'm not going to do it now in the interest of saving time. But you know, we can revisit that if we need to. So I'm going to save this, and I'm going to do testing through actually just running the stuff. Okay, so place. Let's activate the virtual environment. And then source X Alice. No problem so far. And again to the terminal. There's a shortcut to push these to stack like Windows does, but I can't remember what it is. So I'll just keep one smaller than the other, like that. That'll do. So checkouts, Exfiltrator, activate the virtual environment, and now we should be able to do source xbob. And we should see first of all the help, so we can put through. So we have one file name from which to read data, or as a target file name. So we want to go right source xbob. Let's say we're going to put this into a thing called password, because that's one of the ones that would actually should be activated. And what we're going to put into there is the copy of X password. Okay, so according to what we can see here, we've received these chunks. Okay, so we've collected them, and after each one you get some information. So let's just scroll back to the top. You can see we received this one, and it says output password is 512 bytes and is not saved. Output shadow is 0 bytes and has been saved. So remember, they're not dirty because there's nothing to write, so that's okay. The 1024 bytes, 1536 bytes. Until we get to this point of now, look, we've got 2150 bytes and is not saved. So let's check that we can save things. And if you remember, there is now a switch that says if we say W, it should write. And you can see the change here. That's 2150 bytes and has been saved. Okay, so if we look inside, now obviously here we're on the same system, but we're looking inside the output directory. There is a thing called password, and let's cat password, cat output password, make sure it's not gibberish. It's not gibberish, that all looks good. Okay, so it worked. So not complicated if you know the answer, which of course now you do, but hopefully by working through how we get there and what each of these bits does, it makes a little bit more sense. And I think this is a really nice illustration. I think it's a nice illustration of the way that objects and classes allow us to encapsulate functionality. You could easily, if you went out into industry and you were a junior programmer, be given a task to create this object, knowing that it's going to work in a larger system, and you don't have to know how that larger system works. Okay, that's a really nice thing about these, is that you say, right, this is the interface to my functionality, this is the data I store and how I'm going to work with it, and these functions are what I expect people to call, and I can implement those. And you don't care, if someone uses it for this or they use it for a different purpose, it actually doesn't matter. Okay, so I said I was also going to check these things in, so let's try that. So git status. So we've got one thing, which is good, so that's what we expected. So git add source catcher, and git status should now show us that we have one thing that's ready to be committed. Git commit -m for giving a message. If we leave that bit off, you just get an editor. It depends on what your system thinks is the default editor. I tend not to do that just because it risks suddenly jumping into Vi, because that's quite often set as a default editor, and then I can't get out again. But on here, I know it's going to go to Nano, so I don't mind. So I'll put in a commit message, which will be put in personality for catcher class, save it, quit. There it is, and git push should, let's take its time, should mean that we can now go and see in week 9 answer that we have the complete thing. And so anyone that's now watching this video, from this point on, you can now get that remote branch. So remember, git branch -r or git branch -a to see either remote branches or all branches, and then you can also check those things out. Okay, so you might need to do a git pull or a git fetch to make sure you actually got a local copy, or you can check it out from the origin. So you can do git checkout and then the name, including the origin part. That should also work. Okay. Any questions?